let's say 1 plus 4. The starting point is 1. From 1, what is the number at 4th distance? So you have to go for 4 distance, 4 unit of distance. So 0, 1, 2 to 3, 3 to 4, and 4 to 5. So you get 5. Okay. So this is what I mean. So from 1, if you add 4, you get to 5. Similarly, from 2, if you add 4, if you add 4 to 2, what will happen? So 1 step will go to 3, then 2 step will go to 4, 3 step will go to 5, and 4th step will go to 6. So if 4 is added to 2, where do you land? You land at 6. In a number system, when you add digits of a number, like for example 1 plus 2, 1 plus 1, or 1 plus 2, or 1 plus 3. Let's say I'm taking these examples. There is a purpose behind it. We will see that. 1 plus 4, 1 plus 5, 1 plus 6, 1 plus 7, 1 plus 8. Okay, and 1 plus 9. Now just think about this. What is the 9th complement of 1? It is 8. When you add a 9th complement to 1, what is the digit that you will get? You will get the largest 1 digit decimal number, which is 9. Look at this scenario. When you add 9 into 1, the number would be 10. Next number would be 10. Right or not? Like for example, look at this. From 1 you start, and you will go to 9 steps down. If you add 9 to 1, you have to go 9 steps down, and you will land at 10. Okay, this is first step. At 2, then 3, then 4, 1. Okay, first step, second step, third step. So this is basically you are adding. If you add 1 plus 1, you will get to 2. If you add 1 plus 2, you will get to 3. If you add 1 plus 3, you will get to 4. One plus 4 plus 5 plus 6 plus 7 plus 8, and this is plus 9. Okay. If you add any digit to 1, when you are adding any digit to 1 which is less than or equal to 8, what is 8 here? 8 is 9's complement. 8 is 9's complement of 1. 8 is 9's complement of 1. Now to 1, if you add any number, okay, if you add any number which is less than or equal to 1, it is going to be within the digits of a decimal number only, right? It is so because when you add 8 to a number, then you get the largest possible single digit number, right? So if you add anything less than 8, means you are moving less steps from that number. Okay, so when you add 8 to the number, you already reach the largest possible one digit number. So if you add anything less than 8, then you will not be reaching the largest possible one digit number. You will be at some steps or before that. And so, when you add any number to 1, which is less than or equal to 8, you will not be having you will be within the digits of the decimal number, 1 to 9. If you add 0 to 1, you will stay at 1. So, add to 1, if you add anything like 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7, the digits, the where you land would be between 1 to 8, and when you add 8 to 1, you will get the highest possible or largest possible one digit number, which is 9. But if you add 9 to the number, then what you are getting is not a one digit number. So in a number system, when you add digits of a number, let's look at this point in the next page. So in a number system, when you add digits of a number, when digits of numbers are added, say d1 plus d2, d1 plus d2, then if d2 is less than b minus 1's complement of d1, the number of digits in d1 plus d2 would be same as number of digits in d1 or d2. We are not talking about when I am saying d1 plus d2, the number of digits in d1 or number of digits in d2, we are not considering that you can add as many zeros to the left complement number as possible. Okay, so demo of this we have seen in the decimal number system. So to 1, the nice complement is 8. So anything less than or equal to 8, the number of digits are still 1. Which, okay, the moment you add a number to 1 which is greater than the ninth complement of 1, the resultant would be a number which has digits more than the digits in your participating fluid, operands of participating fluid, additives, there is whole possible one digit variable numbers. It will be 0 and 1, 0 and 1, right? Now, if to 0 if you add 0, or to 0 if you add 1, the sum is 0 and the sum is 1, right? So because when you add 1, it means what? When it's going 1 step down, you are still there. Very good. But to 1 if you add 0, now 0 is the 1's complement of 1, and so it will still be 1 only. But if you add 1 to 1, what it means is that you are going one step down. What will be here? It will be what is the successive number in decimal number system after 1, which is 1 0, which is 1 0. So here it will be 1 0. So the number of digits have increased. And as you can see, this 1 is greater than 0, and 0 is 1's complement of 1. Okay? Then the reason is when you add a complement to the number, the result that you get is the largest possible number in those many digits already. So if you are adding something greater than the complement, then of course you will get a number which is greater than the largest possible number in that number of digits. And if it is greater than the largest possible number in let's say n digits, then it can be anything from it has to be at least n plus 1 digit number. Okay, and it will be n plus 1 only. We will see that. If to 3, if you add 5, if you add 4 to 3, what you get is 7. 7 is the largest 1 digit octal number. So this 4 is nothing but, if it is octal means base is 8. So this 4 is nothing but 7's complement of 3 in octal number system. Right? Now if you add, it means if you add any number after 4, be it 5, 6 or 7. So let me take it. Every example. 3 plus 5 or 3 plus 6 or 3 plus 7. Then what would be the result of it? So 3 plus 5 would be what? So one step, you reached 4. Second step, you reached to 5. Third step, you reached to 6. Fourth step, you reached to 7. So fifth step is the number, the successive number after 7. What is the successive number after 7? It is 1 0. It is 1 0. Okay. So 3 plus 5 is 1 0. Similarly, what will be 3 plus 6? 3 plus 6 will be 1 1. 3 plus 7 will be what? 3 plus 7 will be 1 2. Right? This is 3 plus 6. This is 3 plus 7. So 3 plus 6 will be 1 1 and 1 2. Okay. Now let's look at example. Okay. So as simple as that. The b minus 1's complement, in case of octal it is 7's complement. So 7's complement is of 3 is 4. 7's complement of 3. 7's complements of 3 is 4. So when you add the 7's complement of 3 to 3, the number that you get will be the largest one digit number, which is 7. Now if you add to 3 anything greater than 4, then obviously the number that you will get has to be greater than 7. And any number greater than 7, the number of digits would increase. Let's look at hexadecimal number. Let me take 9. Now to 9, what is the complement of 9? So because, okay, what is the base of hexadecimal? Base is 16. Base is 16. So what is the 15th complement of 9? 15th complement of 9 is what should be added to 9 so as to get f, right? So 1, 2, 3, 4, 5, 6. So 15th complement of 9, it has to be 6, because when you go 9 plus 6, what you get is actually 15, and 15 is nothing but f. So if you add, let's say 9 plus 7, the result would be the number after f, and the number after f will be 1 0. Right? Will be 1 0. What is 9 plus 8 will be now? From 9, if you go 8 steps in the downward direction, step 1, 2, 3, 4, 5, 6, 7, 8 step. So this is the, what is the successive number to 1 0? It is 1 and 1. What is successive number to 1 1? It is 1 2, then 1 3, then 1 4, 1 5. Okay, and so on. So this is how it will be. So 9 plus 7 is 1 0, then 9 plus 8 will be 1 1, and 9 plus 9 will be 1 2, So these additions are in for hexadecimal numbers, right? So 9 plus A will be 13. 9 plus B will be 14. 9 plus C will be 15. Okay, done. Now you might ask this question that okay, the number of digits will increase. Okay, so this is one takeaway that we have seen. That okay, so this is one thing. Let me put it uh, in a box. In any number system, when digits of numbers are added, say d1 plus d2, if d2 is less than b minus 1's complement of d1, then d1 plus d2, the number of digits would be same as number of digits in d1 or d2. And we are considering d1 and d2 both to be of same digits. So given that okay, when we are saying digits are to be added, digits is just one single right? So say d1, if d1 is less than, number of digits would be same as number of digits in d1. So actually if d1 is digit, so you can extend this that when digits of numbers are added, in place of digits, just you can write digits or numbers. Digits or numbers are added. Say d1 plus d2. The number of digits in d1 plus d2. Number of digits in d1 plus d2. Okay, if d1 and d2, let's say they are numbers, they are not digits only, they are numbers. In that case, what we are inferring is that the number of digits in d1 plus d2 would be same as number of digits in d1 or d2. So when d1 and d2 are numbers, is given when d1 and d2 are numbers, then both have same number of digits. Both have same number of digits. D2 is greater than D2 is greater than B minus 1's complement of D1. In that case, then D1 plus D2, the number of digits in D1 plus D2 will be more than the number of digits in D1 or D2. Number of digits in D1 plus D2 is equal to 1 plus digits in D1, okay, or 1 plus digits in D2, right? You can check it. For decimal. In case of decimal, add 99 with 99. Okay, and I am going to do this carrying type of addition that you already know in case of decimal. Means it is not possible that you don't know and you are in the weighted form. So how to do 9 plus 9, 18, 1. 1 is the carry, 9 plus 1, 10, plus 9, 19, 198. So this is a 2-digit, this is a 3-digit number. If you take all possible 2-digit numbers and you randomly take any two numbers and you add them, the addition of those two numbers has to be less than 198. I would have taken more examples. Means I would have taken the largest possible hexadecimal 2-digit largest possible hexadecimal and added it. But then, mm, means I want to do it after explaining the addition process of adding numbers, because then right now I've done it for decimal because decimal everybody knows. But for hexadecimal, if I do the series, I will employ the same method of carry. You carry forward to the left side. So, but it is a case that when you add two numbers, okay, if the number of digits in the result will increase, then it will increase by 1, and it will only increase when to the number, when you are adding to the number a number which is greater than the complement of the number, diminished radix complement of the number. Okay, very good. So far we have seen the addition of digits only. So many times I've called those digits as numbers maybe, but we have seen addition like 3 plus 4, or what happens when it is 9 plus 6 in hexadecimal, things like that, or 9 plus 7 in hexadecimal number system. So we have added two digits. Okay, I might have called them as numbers, but we have added digits of a given number system. Now in a decimal number system, what I am going to do is basically I am going to add two numbers. Now let's take 21. Now if you add any number to this 21 which is less than or equal to the 9's complement of 21. Okay, so what is the 9's complement of 21 would be? What the 9's complement of 21 will be? It will be 878, right? So if you add anything to 21, which is less than, let's say you add x to 21, then if this x is less than or equal to 78, then the number of digits in it, if you get y, the number of digits in y will be equal to 2. But if x is greater than 78, then digits in y will be 3. Okay, if the number that you add to 21 is less than or equal to the 9's complement of 21, okay, then number of digits in y is equal to 2, right? And what would be the range of y? Then y will belong to somewhere between 21 included till 99. So when it will be 21? When x is 0. And when it will be 99? When x is the 9's complement, which is 78. Now what do we mean when we actually say 21 plus any number? Let's say 21 plus 0. What do we mean by that? It means that from 21 you will move 9 steps ahead of 21. Okay, so whatever the 9th successive number after 21 would be, that would be the result of 21 plus 9. Okay, so 21, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is where it is 9. 21 plus 10 will be 31. Anyways, so 21 plus 9 will be 31. Okay, if I do something like, let's say 21 plus 40 or 21 plus 45, okay, then what would be the result of it? So as you can see, for any row, oh sorry, in any column, we have 10 numbers, right? So from 21, you will have from here to here 8 numbers like this. So 8 plus 10, 18 plus 8, okay, 8 plus 10, 18, 18 plus 10, 28 plus 10, 28 plus 10, 38, 39, 40, 41, 42, 43, 44, 45. So this will be 66. What does it mean to say that 21 plus 45 is equal to 66? It means that 66 is 45 numbers away from 21. 21 plus 45. So this is ones place. You add the numbers at ones place, and that is 6. And you add the numbers at tens place, and that will give you 6. And this is your result after addition. Okay. Let's take another example like 21 plus let's say 17. So what would be the result of it? So for the ones place digit, you add the numbers or you add the digits at one place, which is 1 plus 0 is 1, and you add the digits at tens place to get the tens place of the result. So it is 9 plus 7 plus 2 is 9. Let's take some other example, right? Let's say 26 plus 40. 26 plus 40. To get the ones place digit of the result, you add the digits at ones place. This will be 0 plus 6. To get the tens place of the result, you add the digits at ones place. This will be 66. Okay. What about 26 plus, let's say 35? 26 plus 35. To get the ones place in the result, to get the value at ones place of the result, you add the ones place here. So 6 plus 5 is 11. Now there is some problem. What is the problem? Okay, let me do it directly because you know the process. So what you do is this: 6 plus 5 is 11. So you write 1 or at the ones place, and you send 1 as a carry to the tens place. And now you add 2 plus 1, 3 plus 3 is 6. This is how you get the addition. This is how you do the addition. Okay. And when you go back from 26, if you move 35 steps from 26, you will land at 61. Let me take out the unit place digit. It is 6. And you are adding to this 6 what? You are adding to this 6, you are adding 5. Now, what is the 9th complement of 6? The 9th complement of 6 is 3. 5 is greater than 3. So it is obvious that the result of 6 plus 5 is going to be a 2-digit number. Okay? And that's what you are getting here. It is going to be 11. At the ones place, you keep this one here. But you take this one as a carry to the left side. That's what you did in your addition. In the addition process, that is what we do. Now let us look into why this method works, or why this method is giving us the right answer. And this is what we will extend it to other number systems also. So for other number systems, the addition of two numbers, we are going to employ this method only. Just like in the 6th video on number system titled as positional number system, every place has a value. So what we are going to do is, for every place we are just adding the numbers that correspondingly. Okay, so 26 plus 35, at one place there is 6 and 5, and we are just adding 6 and 5 to get the ones place number. It happens that the result of adding two digits at the ones place is a 2-digit number. In such a case, what you are going to do, you are just going to take that extra or extra digit as a carry to the left side, immediate left side. Okay, let's look at this. 26 is actually, if you go by the positional number system, if you expand this 26, okay, because it's a positional number system, weighted system, So 26 is nothing but 2 into 10 to the power 1 plus 6 into 10 to the power 0. Right? And when you add, what is 35 then? 35 is nothing but 3 into 10 to the power 1 plus 5 into 10 to the power 0. Right? Now when you are performing this addition, is 2 into 10 to the power 1 plus 3 into 10 to the power 1 plus 6 into 10 to the power 0 plus 5 into 10 to the power 0. So this is going to be nothing but 5 into 10 to the power 1 plus 6 plus 5 is what? 11. Right? 6 plus 5 is 11 into 10 to the power 0. We can write this 11 as what? 5 into 10 to the power 1 plus 10 plus 1 into 10 to the power 0, which is equal to 5 into 10 to the power 1 plus 10 to the power 1 plus 10 to the power 0, or 1 into 10 to the power 0. Now, this is 1 into 10 to the power 1. What it becomes? It becomes 6 into 10 to the power 1 plus 1. Okay, at one's place there is a digit which is 6, then the value is 6 into 10 to the power 0. At the one's place you have 5 here, so the value is 5 into 10 to the power 0. Here at the tens place we have 2. Our weight at tens place is 10 to the power 1. So the value of the digit 2 at tens place is 2 to the power 10 to the power 10 to the power. Similarly, the value of digit 3 at tens place is 3 into 10 to the power 1. If this 3 was not at tens place but at, let's say, ones place, then the value of 3 would be 3 to 10 to the power 0. Now what is happening is this: 2 into, let's say, 10 to the power 1 it will be, plus 3 into 10 to the power 1. Then the result would be 5 into 10 to the power 1. And there is absolutely, this is absolutely correct result, because in essence it is nothing but 20 plus 30, right? So it is nothing but 50. Okay, now in the first place digit you have 6 and 5. Okay, and the addition of 6 and 5 will not give you another one digit, but it will give you 11, which is a 2-digit number. Okay, it will give you 11, which is a 2-digit number. So 6 into 10 to the power 0 plus 5 into 10 to the power 0. This will give you 11 into 10 to the power 0. Okay, 11 into 10 to the power 0. So, which is nothing but 11 into 1, which is equal to 11. Right? But you are adding the digits at what place? You are adding the digits at ones place, but it is adding 1 to the tens place. 1 to the tens place. And that is why you are shifting this 1 on the left side, because the left side, the weight of the left side is already 10 to the power 1. Okay? Let me take another example, this time 3-digit numbers. 363. Let's say this is 10 to the power 0. This is 10 to the power 1. This is 10 to the power 2. Now I will take such an example. I will add such a number to 363 so that you have to take the carry from second to third weight. In this example, the carry was taken from ones place to tens place. Now in this example, what I will make sure is that the carry will be taken from tens place to hundreds place. Okay? And I will show as to why we always take the carry just one place to the left. Okay, and it will suffice. So let me take such an example. So very easily we can take one such example as just do 6 plus 8. 6 plus 8. when you have 8 on the as the test place, 8 plus 6 is 14, so you will definitely send something to the left side. Something one to the left side, carry us to the left side. Okay? Very good. Now let me keep it so that from the first place you don't have to take carry. So let me add 5 here, and let me add 5%. So in the result, okay, the result of this addition, just add the numbers at ones place to get the result, or to get the ones place digit of the result, which is 8. Let me expand it. 363 is nothing but 3 into 10 power 2 plus 6 into 10 power 1 plus 3 into 10 power 0. And 585 is nothing but 5 into 10 power 3 plus 8 into 10 power 1 plus 5 into 10 power 0. Now when you add these two numbers, so in actuality what is happening when you are adding these two numbers, 3 into 10 to the power 2 plus 5 into 10 to the power 2, right? Plus 6 into 10 power 1 plus 8 into 10 power 1 plus 3 into 10 power 0 plus 5 into 10 power 0. 3 into 10 power 2 plus 5 into 10 power 2 plus 6 plus 8 is nothing but 14 into 10 power 1 plus 3 into 10 power 0 plus 5 into 10 power 0. So as you can see, this is 14. You can write this 14 as 10 plus 4, right? So 3 into 10 power 2 plus 5 into 10 power 2 plus 10 into 10 power 1 plus 4 into 10 power 1 plus 3 into 10 power 0 plus 5 into 10 power 0. This will become 3 into 10 power 2 plus 5 into 10 power 2. This is nothing but 10 power 3. I can write it as 1 into 10 power 3. Now this 1 is coming from here, right? Because we have expanded this 14 as 10 plus 4. So when you have got a carry in the 10th place, 10 to the power 1, then you will send that carry 1 to the 100th place. Why? Because it will eventually become 1 into 10 to the power 2, and it will eventually add it among this only. This will become 1 into 10 to the power 2 only. Okay? 4 into 10 to the power 1, and then plus 3 into 10 to the power 0 plus 5 into 10 to the power 0. So this is what it is. And hence 5 plus 3, 8 plus 1, 9. 9 will be here. And 4 will be 9, 48 is the answer. Let me take another. Now we will look at addition of two octal numbers, hexadecimal numbers, and binary numbers. Okay. So this is all possible 2-digit octal numbers. Let me take an example. For example, let's say this is one octal number 0, 7, and I want to add to this octal number, I want to add 1 0. Okay. Now what would be the answer? Okay, what is the result of the sum of these two numbers? So 1 0 actually is, if you convert this 1 0 into decimal, then this 1 0 is actually 1 into a power 1 plus 0 into 8 power 0, which is equal to 8 plus 0 equals to 8. So this is what 1 0 is in the octal. Now it means what? 07 in octal plus 10 in octal means what? It means that you have to move 8 steps ahead of 07, right? So where is 07? Here it is. We have to move 8 steps ahead of 07. 1, 2, 3, 4, 5, 6, 7. So the answer would be 16 in the octal number system. If you do, let's say 07 plus, let's say 23, in both are octal numbers, then what is the result of the addition of these two numbers? How will you find the result of it? So 23 actually is in decimal. What it is 23? It is 2 into 8 power 1 plus 3 into 8 power 0, which is nothing but 16 plus 3, that is 19. It means when you move 19 steps ahead of 07, then you, whatever number that you will reach to will be here. Okay. So from 07, you have to move 19 steps away. Okay. Now, at any column, how many numbers are there? 8 numbers. Okay. At any column, you have 8 numbers. So 8 numbers, 16 numbers plus 3. So the answer is 32. Answer is 32. This is the, the visualization of what happens during the addition. But the method of adding two numbers is through, just adding the digits at the place. And if you get a carry, then you forward the carry to the left side. That's how we actually add two numbers. Let's take this example only and do it with carry method. So 07 plus 10, both are in octal. Now how will you add? So this is the result of it. This is the result of the addition. Now what will be at the ones place? What will be at the 8 to the power 1s position? What digit would be at 8 to the power second position if at 8 to the power 1s position, adding the digits at 8 to the power 1s position, if it gives a carry, then the number of digits in the result would be 3. Now when you add the digits at leaf place, then it is 7 plus 0. 7 plus 0 is nothing but 7. Okay, so 7 plus 0, 7 in octal plus 0 in octal, it means you don't have to move any step ahead of 7. Then what is the result? It's still the 7 only. So at the ones place, we will have 7. Similarly, at the 8 to the power 1s position, this is 8 to the power 1 position. So at 8 to the power 1s position, when you add 0 and 1, what it will be? It will be 1. So there will be no carry, right? So the answer to this is 07 plus 10 is 17. You got 16 here, and now you are getting 17 here. Or we did some mistake in calculating. Let me see. So 10 in decimal is 1 into 8 power 1 plus 0 into 8 power 0, which is nothing but 8 plus 0, which is equal to 8. So 1, 2, 3, 4, 5, 6, 7, 8. So actually 17 should be the answer. So this is correct it here. Okay. Now take this example and add it using the carry method. So zeros carry method. Okay. So 07 plus 2, 3. 2, 3. Now at the unit place, it is clear. Now just look at this. If you look at the unit place digits, it is 7 and 3. Unit place digits are 7 and 3. And 3 is greater than 7's complement of 7. 3 is greater than 7's complement of 7. So definitely the result of 7 plus 3 is going to be a 2-digit number in octal. Okay? Good. So the result of 7 plus 3 is going to be a 2-digit number in octal. So you are going to get a 2-digit number. So the extra digit at the second place will be forwarded as a carry. Right? Now if I ask you what is 7 plus 3? So one way to go is to look at all the possible numbers, and from 7 you move 3 steps. So 1, 2 and 3. So 7 plus 3 is 7 plus 3 will be equal to 12. Now this 1, 2 or 7 plus 3 equals to 1, 2, this is in octal. This is in octal. So this is one way to do addition of 2 octal digits. You can perform the addition of 2 octal digits if you can just list down first. Listen. So if you just list down these many numbers, then you can perform the addition of 2 digits in octal. Okay, and directly get what octal value would be by addition of 7 plus 3. This is one way. The other way to add is convert this 7 into decimal, convert this 3 into decimal, and it is easy for everybody to do the addition in decimals. Find what is the result and then change the result into octal. Okay, so what it will be? 7 plus 3, because fortunately in the digits of the octal, the decimal conversion of the digits of the octal is nothing but the digit itself. It is same in the decimal also. Okay, and in decimal 7 plus 3 is 10. In decimal 7 plus 3 is 10. And when you convert this 10 to octal, what you will get? 8 into 1. 8 into 0. 1. So it is 12. Okay. So this 12 is here. So what you do, at the ones place 2 will be there. And what will go as a carry? 1 will go as a carry to the left side. Okay. Now you perform the addition of the 8 to the, all the numbers at 8 to the power 1th position plus the carry that has arrived. 1 plus 0 plus 2. That is nothing but 3. I want you to note this. In case of octal, because the number of digits in octal is less than the number of digits in decimal, so the symbols for the that is used in octal, the same symbol is used in the decimal, right? So, but in case of hexadecimal, there are symbols after 9, there are symbols A, B, C, D, E, F. These symbols are not there in decimal. Like in the hexadecimal, when you are doing the addition using the carry method, at any place, let's say at place 16 to the power 1, if the numbers that you are adding is A and B, okay, then this A, what it means is that you are basically adding 10 and 12, 10 and 11, okay, and when you add 10 and 11 it will be 21, and all of this that you are doing, it is in decimal. So 21 has to be changed first into hexadecimal, and you will see if it is a single digit or if it is a 2 digit, and it is actually 2 digit. And what is that? It is 1, maybe 1 and 6. It is 1 6. I mean A plus B is 1/6 in hexadecimal. A and B are in hexadecimal. Then A plus B is 1/6 in hexadecimal, and this 6 will be in the first position, and this 1 will be sent as a carry to the second position. Okay, but first we will see the method of addition by we will see the visualization of addition, that what it means when you write anything as 0, 7 plus 3. It means that you are basically moving those many steps ahead of that number. So this is the all possible 2-digit hexadecimal number. This is all possible 2-digit hexadecimal number. Obviously, it is going to be a lot because number of digits in hexadecimal is 16. So all possible 2-digit hexadecimal numbers, it is going to be of the order of 16 by 16, right? Every column is going to have 16 numbers. So there are 256 numbers that I have written just so that I can explain it better. Just so I can explain one in the visualization of addition. So you can I can say that you can like and subscribe for this. Let's take examples of hexadecimal. So let's take a number which is AB a hexadecimal number AB plus CD. AB plus CD. So look where AB is. AB is here. So this is your number. Now what is what it means by CD? Is actually C into 16 power 1 plus D into 16 power 0, and C is actually you can say C is 10, 11, 12. So 12 into 16 power 1 plus D is what? If C is 12 and D is 13 into 16 power 0. So this is nothing but 12 into 16. 16 percent 6. 192. 192 plus 30, which is equal to 205. So I cannot do it practically in this case. So from AB you have to move 205 steps ahead, and then whatever you will get, that will be the answer. So I am not going to I cannot show it. I cannot show it in this or within the all possible 2-digit numbers, because this is only all possible 2-digit. How many all possible 2-digit hexadecimal numbers are there? It is 256. So 160 plus, I think what AB is 171th number in hexadecimal number. If you list all successive hexadecimal numbers, then AB is 171th number. So definitely from 178th number, if you add 200, you are going outside of the range of all possible 2-digit hexadecimal number. I cannot show this by moving these many steps using this diagram. So I will. So definitely it means that you are going to get, in this case, a number which is going to be a 3-digit number. So I will use this example. We will do the addition, but I will do it using the carry method. So wait for a while. Let me show you 1-2 examples with moving these many steps ahead. So 1E means what? It means that you have to move 1 into 16 plus 43. A is 10, B is 11, C is 12, D is 13, and E is 14. So 14 into 16 power 0. This is equal to 16 plus 14, that is equal to 30. It means from AB you have to go 30 steps ahead of AB to get the result of the addition. So AB and 30 steps ahead of AB. So one column is having 16 numbers. So 16, 1, 2, 3, 4, plus 4, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So the answer will be C9. Answer will be C9. So AB plus 1E is C9. Is C9. Now let's perform this addition. Let's perform this addition using the carry method and verify. So if you look at this position only, then B plus E is what? So B is actually 10, 11, and E is actually 14. So 11 plus 14, and 11 plus 14 is, we are doing in decimal addition. We are converting B into decimal, we are converting A into decimal, and we are performing the decimal addition. So 11 plus 14 is 25. So 25 in hexadecimal is what? So in hexadecimal 25 is 16 into 1, 16, 9, 16 into 0, 1, so 1 9. So 1 9, so 9 will be here and 1 will go as a carry. And now we perform A plus 1 plus 1. So A plus 1 is B, B plus 1 is C. So you get C. Okay. Now let's do this addition. AB plus CD. AB plus CD. Definitely you are going to get a 3-digit number. So let's perform this. AB plus CD. When you look at this position, this place, AB plus CD, when you perform the addition at this position, B and D. So B plus D, B plus D is what? B is 11 and D is 13. So 11 plus 13, it is B14, 114, 24, which is 818 in hexadecimal. So this is, here you will get 8, and so that the carry will be 1. You get a carry here. At this position now we have to do the addition at this position along with the carry, and to get what the digit would be in the result. And this is what would be the digit at this place in the result. So basically you have to do A plus C plus 1, which is actually 11 plus 13 per gram. This is 10. 10 plus 12 plus 1, which is nothing but 23, right? And 23 in hexadecimal will be 16 into 1, 7, 16 into 0, 1, 1 7. So 1 7. So this will be 7, and the carry 1 will go here. So this is what the answer is. So AB plus CD is equal to 178 in hexadecimal. Okay. Okay, now let's look at the examples of binary. 1 0 plus 1 1. What is the answer to this? Okay. Now, what it means is that from 1 0, you have to move 1 to the power 1 plus 1 to the power, which is equal to 2 plus 1, that is equal to 3. It means from 1 0, you have to move 3 steps. From 1 0, you have to move 3 steps. 1, 2, and 3, and whatever the number you get in the binary number system, that is the result. Right? It will be 100, 101, and 110. So 10 plus 11 is 110. Now do the addition using carry method. Then it will be 10 plus 11. So 0 in the equivalent of 0 in decimal is 0. The equivalent of 1 in decimal is 1. 0 plus 1 is equal to 1 in decimal, and that is what it is in binary 2. So 0 plus 1 is 1. 1 plus 1. 1 plus 1. The equivalent of 1 in decimal is 1. The equivalent of 1 in decimal is 1. When you add these two, you get 2. And what is the equivalent of 2 in binary? It is 1 0. It means that at this position it will be 1, and this 1 will be is a carry. So 101 is the answer. 101 is the answer. Okay. When you have to add two numbers, what we are doing is we are finding the digits at places of the result of the addition. And how are we finding? We are basically just adding the digits at the corresponding place of the numbers that are there in the addition. In doing so, it might happen when you add two digits, it might happen that the addition of two digits at any place will give you a digit, or it will give you a two-digit number, right? If it is a two-digit number, then we are taking the extra bit and we are sending it as a carry, and that carry is also to be added along with the digits at the left place. If you look back into every example, if the carry is coming when you are adding the digits, if the carry comes, then it is always going to be 1. If the carry comes, then it is always going to be 1. Okay, you check it out if you have all the examples and you can solve on your own many problems. You will see that always the carry will be 1, regardless of the number system. Means we have seen examples of binary, examples of decimal, examples of octal, or examples of hexadecimal. But the carry in any base, be it base 6 or base 7, when you add numbers, let's say in base 6, you are adding, when you are adding two numbers in base 6 also, if by adding the digits of any place, if you are getting a two-digit number, the number at the second place will always be 1. Okay, and let me show you how it is. Okay, whatever, when you are adding two digits in a decimal, what is the highest value that you can get? It is when you add 9 and 9, and that you will get as 18, right? So the carry generated will be 1. In case of octet, what is the highest number that you get when you add 7 and 7? That is 16. So the carrying, if the carry is generated, then digit is 1. In case of hexadecimal, just do this f plus f and see what happens. Right? Just do this f plus f and see what happens. You know what is f? F is 60. No, f is 15. F is 15. In decimal, f is 15. Okay, what is 15 plus 15? It is 30. It is 30. So what is the value? What is the hexadecimal equivalent of 30? What is the hexadecimal equivalent of 30? 30, 16 into 1, 16. This is 14. So you can write 14. So 14 is nothing but E. And then 16 into 0. This is 1. So 1 E. 1 E. So this is f plus f is, so all the number will come at the end. F plus f, this is nothing but 1 E. I have just shown you by adding the largest digit of every base of decimal. Oh, we have not seen binary till now, right? Okay, next you will see bandwidth. So I have just shown you 9 plus 9 is 18, or 7 plus 7 is 13, or 16 in octal, and f plus f is 1e. And I've shown you always the carry will be 1. But let me give you an intuition. Why always the carry is 1? Means you don't have to go and do the addition of the largest number to find it out. Just think about this. When you are listing all the numbers in a number system, how do you do it? You write a successive number, right? I mean, this is something you know because this is already covered in the first, second, third video of number system. From that foundational knowledge itself, we will see as to why always one will be the carry. If carry is generated, then it is one. Okay. For example, let's take decimal only 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now let's think about this. After 9, when you start to list the next number, it will start with 1. It will start with 1 at the second place. Let's say this is the first place. This is now second place and first place. So 1 at the second place with all the possibilities at the first place, and this all the possibilities will include all the digits here. 2, 3, 4, 5, 6, 7, 8, 9. Now, so now with 1 at the second place, at first place you have all the possibilities. Then what happens? When you add 9 plus something, it will fall within this only. Even 9 plus 9, let's say 9 plus 9, it will fall from 1 to 0 to 8 only. Right? Because here at the second place 1 is constant. 1 is constant. But at first place, how many numbers will be there? It will be those many numbers that are the number of digits in the number system. And when you are adding 2 digits, so number of steps will not exceed, will not cross the number with 1 at second place. In case of binary, what is the largest possible addition of digits would be? It would be 1 plus 1. Okay, means just going one step away from which is 1, 0. There are only 2 digits, so either you can have 0 plus 1, or you can have 1 plus 1, or you can have 1 plus 0. Because addition is commutative, so both are same. So the carry will be generated when you add 1 plus 1, and 1 plus 1 is 1, 0.